We've climbed the highest mountains. We've even walked on the moon. But what if the next great frontier isn't out there in space, but right here, deep beneath our own feet? Well, that's exactly where China is looking. They're on an ambitious mission to drill one of the deepest holes in human history. So let's dig in.
So the big question is, why? What are they really after? Is this a crazy quest for scientific knowledge? A hunt for some precious resource? Or is it something else entirely?
Out in the remote Tarim Basin, engineers are aiming for a depth that is just mind-boggling. 36,000 feet. We're talking over 11,000 meters, punching straight down through more than 10 different layers of rock.
To really get your head around that, picture Mount Everest. Now, imagine trying to drill a hole that deep. It's a feat of engineering that is so extreme, it is pushing our technology to its absolute breaking point.
Okay, so to really understand what's going on, here's how we're going to break it down. First, we'll look at what China's trying to achieve right now. Then, we're going to hit rewind and look at the Cold War-era race to the center of the Earth. After that, we'll uncover the ultimate scientific prize everyone's been hunting for. And finally, we'll explore how all of this just might unlock a revolutionary new source of energy for all of us.
So let's start with the here and now. What is driving this absolutely massive undertaking?
Well, this project is playing the long game. On one hand, you can think of it as a scientific time machine. It lets researchers literally read Earth's history chapter by chapter in the layers of rock. But on the other hand, it's a very practical hunt for the deep oil and gas reserves China needs. And if that wasn't enough, it's also a way to better understand the massive forces that trigger things like devastating earthquakes and volcanic eruptions.
And make no mistake, this is a huge national priority. Back in 2021, President Xi Jinping himself basically challenged the country's entire scientific community to push the boundaries of deep Earth exploration. It's become a key part of China's technological ambitions.
But here's the thing, China isn't the first to take on this incredible challenge. This whole mission is really just the latest chapter in a long, incredibly difficult, and surprisingly competitive race to the center of the Earth.
This whole thing is kind of like a technological relay race. It really kicked off during the Cold War. You had the US and the Soviet Union locked in this deep drilling competition that was a lot like the space race. After them, there were projects in Germany, and now the baton has pretty much been passed to China, which is launching this next major push. For decades now, the undisputed champion of deep drilling has been Russia's Kola Superdeep borehole. It reached a staggering 40,000 feet. But get this, it took them over 20 years of grueling work just to get there. That just tells you how unbelievably hard this kind of exploration really is.
And you know what? What they found on the way down was maybe even more important than just reaching a certain depth. They found microscopic fossils miles beneath the surface. They found water where scientific theories said it was impossible for it to exist. And they even uncovered crucial evidence that helped confirm the theory of plate tectonics.
So why did they stop?
Well, in one word, heat. Down at the bottom, the temperature shot up to 180 degrees Celsius. That's 356 Fahrenheit. It was way, way hotter than they predicted, and their equipment just couldn't handle it. It basically started to melt.
But beyond the national pride, beyond looking for resources, there's an even bigger prize that's motivating all of these projects. It's a goal that geologists have dreamed about for generations, to be the very first to touch the Earth's mantle.
It's kind of crazy when you think about it. The crust we live on, everything we've ever seen or built on or explored is just a paper-thin 1% of our planet's volume. The real engine of our world is the mantle. It makes up a colossal 85%. It's the vast, hidden majority of our own home.
And you should forget any idea of a liquid ocean of magma. The mantle is actually solid rock, but it's under such incredible heat and pressure that it flows very, very slowly over millions of years. The best way to picture it is like a planet-sized lava lamp, with the continents just kind of floating on top of its slow, churning currents.
And this is exactly why drilling is so important. To actually get a pure, untouched sample of the mantle, well, for a geologist, that would be a scientific achievement on the same level as the moon landing. It is the absolute holy grail of their field.
Now, we have found pieces of the mantle before. These are rocks that were violently thrown up by volcanoes or pushed up over millions of years. The problem is, they're all contaminated. They've been changed by their chaotic journey to the surface. A drilled sample, though, would be pristine, a pure, unaltered snapshot of the very material that built our world.
So this science is obviously really exciting, but the technology they're developing to pull it off could have an even bigger impact on all of us, one that could totally change our energy future.
See, mastering this kind of deep drilling could be the key to unlocking a holy grail of clean energy, something called supercritical geothermal. The basic idea is, if you drill deep enough, you reach water that's so hot and under so much pressure that it enters this weird supercritical state, holding enormous amounts of energy. Tapping into that would be like plugging into a natural planet-sized battery, one with all the power of fossil fuels, but with zero emissions.
The potential here is just staggering. I mean, imagine tapping into a virtually limitless supply of clean, reliable energy anywhere you want on Earth. We could lift billions of people out of energy poverty, we could drastically cut greenhouse gas emissions, and we could completely reshape the entire global economy. This isn't just a small improvement. We're talking about a revolution.
So it leaves us with a pretty fascinating question. For decades, we've been looking up to the sun and the wind for clean energy. But what if the real answer, the future of our planet's energy, has been right under our feet this entire time?